We'll solve some MCQs based upon the chapter Coordinate Geometry. Here's the first one. The question says the line segment joining the point 3 minus 1 and minus 6 phi is trisected. The coordinates of the point of trisection are. So let's consider this as point P and let's consider this as point Q. So if we have the line segment like this, P and Q, they're saying it's trisected. That means it's divided into 3 parts. So let this be A and let this be P. So this part will be 2 because it's dividing this half into 2 units. This will be 1, it's dividing in 1. So PB is to BQ will be 2:1. That's your M is to N ratio, 2:1. Now we have to find the coordinates of the point. That means point of trisection. That means we have to find the coordinate of B. So the formula would be, for x it would be mx2 plus mx1 upon m plus n, and for y it would be my2 plus my1 upon m plus n. So let's substitute. M is 2, so 2, x2 is minus 6, x2 is minus 6, so minus 6 plus n is 1, x1 is 3 upon n plus 1, n plus m, which is 2 plus 1 becomes 3. So you get, this becomes minus 12, this becomes plus 3 upon 3, this becomes 9 upon 3, minus 9 upon 3, x becomes minus 3. Okay, y here, m is 2, y2 is 5 plus 1, and this is minus 1 upon 3. This becomes 10 minus 1 upon 3. This becomes 9 upon 3. Y becomes 3. So our coordinates for point B, or the point of trisection, is minus 3, 3, which becomes option B, minus 3 and 3. The next question here. The point 1, 1, minus 2, 7, 3, minus 3 are. So we have to tell whether it's a vertex of an equilateral triangle, whether they are collinear, or they are vertices of isosceles triangle. So let's take this as A, B and C. We'll use distance formula and find the distance between these points. So AB, the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square inside the square root. So let's do this. Let's do this. This will be minus 2 minus 1 the whole square plus 7 minus 1 the whole square. This would be 3 square, that's 9, and this would be 6, 6 square is 36. So AB would be, this becomes 45, root 45, which can be written as 9 into 5, which can be written as 3 root 5. So AB is 3 root 5. Now let's do BC. Let's change the color. Yeah, let's do BC. So BC, I can take it as here again. So 3 minus 2 the whole square plus minus 3 minus 7 the whole square. So this becomes 5. 5 square is 25. This becomes 10. 10 square is 100. So this becomes 125. BC becomes root 125. This can be written as 25 into 5. So BC becomes 5 root 5. We've got this. And lastly, let's change the color again. We have AC. So AC, I can write it as 3 minus 1 the whole square plus minus 3 minus 1 the whole square inside the square root. This becomes 2. 2 square is 4. This becomes 4. 2 square is 4. This becomes 4. 4 square is 16. This becomes 20. AC can be written as 4 into 5, which can be written as 2 root 5. Okay, now if it has to be equilateral triangle, then all the distance should have been equal, which is not, so that's not possible. If it has to be isosceles triangle, then two measurements has to be equal, which is also not the case here. So if we see AB plus AC, AB plus AC, that's 3 root 5 plus 2 root 5 gives me BC, which is 5 root 5. And this is the exact condition for collinear points. So these 3 points are basically collinear, option B. The next question, if the distance between the points x minus 1 and x comma minus 1 and 3 comma 2 is 5, find the value of x. So distance is 5, it will be x2, so this 3 minus x the whole square plus 2 minus minus 1 the whole square inside the root. We'll take square root on both sides. We'll square both sides. We'll square both sides, not square root, so it becomes 25. This I can write it as 9 minus 6x plus x square plus this becomes 3. 3 square will be 9 here. So let's arrange this. X square minus 6x plus 18 minus 25 is equals to 0. This becomes x square minus 6x. This will become 7. Minus 7 is equals to 0. So we'll have to split this, factorize this. So I get x square minus 7x plus x minus 7 is equals to 0. I get x square, no, I'll get two brackets, which will be x minus 7 in one and it will be x plus 1 in the other one. So x is equals to 7 or x is equal to minus 1, two values. That's option D, either 7 or minus 1. Next, area of the triangle whose vertices are A 1, 2, B minus 2, 3 and C minus 3 minus 4 is. Okay, so for this the formula will be area of triangle. The formula is half into x1. Since I'm taking x1, I'll be taking y2 minus y3, then x2, so it will be y3 minus y1, and I'm taking x3, so that will be y1 minus y2. That's the formula. Let's substitute. So I have half, x1 is 1, so 1 bracket, y2, so 3, and this is y3, so 3 minus minus 4 plus x2 is minus 2, y3 is minus 4, and this is minus 2 plus minus 3, 2 minus 3 here. Okay, now we'll solve this further. So I get half, 1 into 3 minus minus 4 becomes 7, so 1 into 7 is 7. This is 6. 6 into minus 6. Minus 6 into minus 2 becomes plus 12. This becomes minus 1. Minus 1 into minus 3 becomes 3 here. 7 plus 3 is 10. 10 plus 12 is 22. So I get half into 22. 1s are 11s are. So the area is 11. Option A. The next question we have here, the last one. If A, B, C, so if I have a parallelogram like this, the diagonals basically bisect each other. So when we say bisect, that means both of them are going to have the same midpoint. So in short, midpoint of AC is going to be equal to the midpoint of BD. So let's take the x's first. So for AC, A and C, it's going to be minus 2 plus 4 upon 2, and for BD it's going to be P and 1. So P plus 1 upon 2. So this will become 2 upon 2. This will become p plus 1 upon 2. This becomes 1. So 1 is equals to p plus 1 upon 2. So this I get it as 2 is equals to p plus 1. So this becomes 1. P becomes 1. Similarly, we have to find for y. So let's take y this side here. So y is minus 1 and q. So minus 1 plus q upon 2 is equal to 0 and 2. 0 plus 2 upon 2. This becomes 1. So I have minus 1 plus q upon 2 is equals to 1. Minus 1 plus q is equals to 2. This I can write it as q is equals to 2 plus 1. Q is equals to 3. So the value of p is 1 and the value of q is 3, which is option number C, 1 and 3.